Welcome to my channel. In this video I'm going to talk about organic chemistry. So to start with, we are going to define what organic chemistry is. Okay, so organic chemistry is simply the study of carbon and its compound. Organic chemistry, the study of carbon and its compounds. So these compounds are in families called homologous series. These compounds are in families called homologous series. So homologous series, by definition, are a group of compounds with similar chemical properties and the same general formula, but show a gradual change in their physical properties. So a homologous series is simply a group of compounds with similar chemical properties and the same general formula, but they show a change in their physical properties. Examples of homologous series: we have alkanes, we also have alkene, alcohol, which are also called alkanes, and we also have what we call carboxylic acids. So we are going to look at these group of families which are called homologous series. But before we do that, let's look at some terms which we should know. Terms like hydrocarbons and functional group. So a hydrocarbon, these are compounds which consist of carbon and hydrogen only. So hydrocarbons, these are compounds which consist of carbon and hydrogen only. And a functional group is simply a group of atoms which determines the chemical properties of organic compounds. So make sure you know these terms so that you understand what we are going to talk about in the next group of alkanes. So let's start. Let's also know what we call prefixes. So these prefixes will help us to name some organic compounds. So we have the first prefix, which is meth. So when naming the organic compounds, we are going to use these prefixes, but these numbers like 1, 2, 3, 4, 5 up to 10 stand for the number of carbons which are in that compound. So the compound with one carbon will have its name start with meth, and with two carbons it will start with eth, and so forth. Okay, so let's start by looking at the first group of organic compounds, which are called alkanes. So alkanes, by definition, are simply saturated hydrocarbons. So these are saturated hydrocarbons. Remember, we said hydrocarbons are compounds which consist of only carbon and hydrogen elements. So alkanes are saturated hydrocarbons, meaning they only consist of carbon and hydrogen, and they are saturated. So what do this term saturated mean? So saturated means they have a required maximum number of hydrogen atoms. So the term saturated means they have the maximum number which is required in their compounds. So saturated alkanes, they have a maximum number of hydrogen atoms in their compounds. So they also end in ANE. When you name an alkane, it will always end with the ANE. So this is a suffix. So to name alkanes, we are going to use these prefixes. Like if you have a compound of alkane with one carbon, then we are going to get this meth. Remember, it's a suffix, it's a prefix, and then we get this suffix, the end, in which alkanes end. So to name a carbon, an organic compound with one carbon, we are going to get that meth, and the ending of an alkene, which is ANE, this. So we get that, and then we add it here. So the first alkane will be methane. So that's how you name alkane compounds. Okay, so they end in ANE. Whenever you see a compound with ANE under organic compounds, that is an alkane. Okay, so the general formula is CnH 2n plus 2. So the n in this formula represents the number of carbons which are in that compound, the number of carbons which are in that compound. So let's also look at the functional group of alkanes. So functional group is this one, which is here, a single carbon to carbon bond, a carbon to carbon single bond. So that's a functional group. Whenever you see that in a compound, then just know that it's a functional group of alkane. So remember, a functional group, we said this is a group of atoms which determines the chemical properties of that organic compound. So they have a single carbon to carbon bonds. Okay, so let's draw some structures. How can we come up with a structure of an alkane? So before we do that, we also have to note that carbon makes 4 bonds, a maximum number of 4 bonds. Carbon will always make maximum number of 4 bonds, and hydrogen will make only a single bond, and oxygen will only make 2 bonds. So you understand this when we start drawing the structure formula. Like for example, the example is saying write the structure formulas of the following. Write the structure formulas of the following. Like number 1 is methane. Number 1 is methane. So in drawing these structure formulas, we're going to follow the same procedure where carbon makes only 4 bonds and hydrogen a single bond. Okay, so let's draw a structure. But before we draw a structure, we need to come up with the formula for methane. Formula for methane. So what's the chemical or molecular formula of methane? So we use this formula here, general formula, to come up with a molecular formula for alkanes or organic compounds which are called alkanes. So we are going to use this formula to come up with the molecular formula. After knowing the molecular formula, that's when we can draw the structure of that compound. So to use that formula here, we have methane, and that's the formula, which is CNH plus 2 H2N plus 2. So where there is N, we are going to replace with 1, because we know that methane has only 1 carbon, has only a single carbon, as we saw under these prefixes. Where we have meth, then you just know that that compound has a single carbon, and this F will have 2 carbons, and prop will have 3 carbons. So meth has a single carbon. So to draw its structure, we are going in a structure, we are going to have a single carbon in that structure. So we are going to replace where there is any there. We said any is the number of carbons, so we know that in methane we have only 1 carbon. So where there is any here, we have replaced with 1. So we are going to have C1 H2 where there is N1 plus 2. So that will give us this here. So this is the formula for methane. So how can we draw a structure formula? So whenever you are drawing a structure formula, you need to put or to draw carbon first. So you draw your carbon on the middle, then you show its bond the other sides of it, and then make sure your carbon must have a maximum number of 4 bonds. As you can see, these arrows here represents the bonds. So we have 1, 2, 3, 4 bonds. Okay, so that is the maximum number of bonds that a carbon atom will make. So on the tip of this carbon, we are going to write or draw the hydrogen atoms. You draw the hydrogen atom, and remember, a hydrogen should have a single bond. So when you look at it, it has a single bond. This bond here is shared between carbon and this hydrogen here. So a hydrogen must have a single bond. In this case, they all have single bonds. So that is the structure of methane. So this will be a structure of methane. So let's also look at the second question, which is propane. So propane, when you check under those prefixes, it is on number 3. So it will have 3 carbon in its compound. So where there is N, we replace with 3. So it will be C3H8. So to draw its structure, we are going to draw the carbons first on the middle, the 3 carbons on the middle. Remember, there we have 3 carbons and 8 hydrogens. So remember, draw the carbons first in the middle. After that, show their bonds. So the maximum number is 4 bonds. After drawing that, now put the hydrogens at the tips of those bonds. So this will be the structure of propane. So when you count, the number of hydrogens should be equal to the number of hydrogens in that formula. Here we have 8 hydrogens, and then when you check in this formula, we must have 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is the structure of propane. Okay, so let's also have an exercise here. So you can pause the video and draw the structure of this compound, which is octane. So you check on these prefixes and see the number of hydrogens which are on oct, and then this ANE here, it is simply the ending or the suffix of alkanes. So draw the structure. After that, then pause the video, draw the structure, and come and check the answer. Okay, so this will be the chemical molecular formula for octane, and then the structure formula, this will be the structure formula. Remember, it should have 8 hydrogens and it must have 18 hydrogens. So if you count these hydrogens and carbons, they must be equal to the numbers which are shown in that formula there. So thank you very much for watching this video. Remember, don't forget to like and subscribe, or if you don't like this video, hit that unlike button.